Okay. Well, we might as well just go and get started. So, one of the things I want to do real quick is actually make an approved suppliers. Um, One of the things I've heard done is making an approved suppliers uh, SOP. And it actually started making a master supplier list that's associated with it. And this is where we're going to keep track of um, uh, all the vendors that we are approving to supply us materials with our product. Um, I wanted to kind of get it kind of done. I don't want to bore anybody with all the small process, but we'll go through and uh, update, fix things as we go. SOP. I wanted to do this. Oh no, SOP dash SUPP dash 01 underscored suppliers MD V 1.0. Okay. So I went ahead and, kind of off camera created the approved suppliers SOP, kind of formalized a little bit for the actual suppliers. Uh, Kind of pull out of here. We'll go through and clean that up later. This way, everything kind of gets lined up and falls in. I'll go through. We can go through and clean this up later. I don't want to waste too much of the stream doing this, but this is part of the process. You definitely want to document everything. You want to have an SOP that defines how you approve a supplier, basically who has the authority, the responsibilities of approving suppliers, uh, how they handle if a supplier makes errors, makes mistakes, if they ship you products that are bad, that don't meet things like conflict materials, requirements, things like that. So there's a lot you have to do to help protect yourself to make sure you're buying parts that are legitimate. There are a lot of companies out there that have their parts, how should I say, imitated, knockoffs, copies, duplicated, however you want to call it, whatever term you want to use. Um, Analog Devices, Silicon Labs, their stuff is pirated pretty much all the time. You will find fake ICs that will look and function very much like the OEM version, but they will be pirated versions. They will be copies. They're cheaper, they're lower cost, and you honestly pay for the lower cost. You don't get nearly as good of a product, and sometimes they will actually behave slightly different than the official version. Uh, I actually ran into this with a project working on. Uh, we bought some dev kits off of Amazon, tested them out. They looked like they were going to work. We were getting the data out of them that we thought we wanted. Uh, Designed a board around the part we were testing, a sensor. Got on the internet through Mauser, ordered the sensor we thought we were testing, and it behaved completely different. Ordered a couple additional sensors from a different vendor like DigiKey, built up a couple additional boards, tested, they acted differently than the board, the development kit. Put them under the microscope and checked the markings on the chip, and sure as goodness, the Amazon low cost dev kits, the chips had different markings than the official ones from Analog Devices. It was pretty crazy. We contacted Analog Devices about it, talked to one of their tech reps, and they told us, yeah, it happens all the time. Texas Instruments, you name it. They all get their stuff copied and duplicated. So you want to kind of protect yourself and make sure you're buying from reputable vendors. I'm not saying Amazon's a bad place to buy stuff, but if you're looking to build a business and have repeatable results that your customer can rely upon, um, look for reputable vendors that you can get parts consistently that are actually by the manufacturer that they say they're from. Amazon's good to get development kits and test parts, but nothing against Amazon, but I would not use them as a supplier for a manufacturing house. I would be okay for like maybe screws, like M3, M4 metric screws and hardware. I'd be okay with that. But if you're talking like chips, ICs, other parts here and there, no. I go with reputable vendors like Mauser, DigiKey, Aero Electronics, Newark Electronics, Future Electronics. Go with a reputable vendor that's been established in the industry for a long time. There's also something we call a gray market, where sometimes the source of the products are questionable. Sometimes what they are is they're materials that were acquired from a company that was shutting its doors. So the status of the parts is unknown, the solderability is unknown, whether or not they had the proper process with moisture sensitive devices followed. It's all unknown. Sometimes you have to spend additional money to send samples of the parts out to a test lab to make sure they're actually usable in your process. So that's why you want to make sure you have all this wrangled, all this controlled. Know where your parts are coming from and know how to handle what you need to do if something goes wrong. So you'll get things like certificate of conformance from a vendor, certificate of conformity. Basically, it's the vendor saying, hey, the parts you bought for us do meet the requirements. They're conflict-free minerals. They're made in the country they say they're made in. They're brand new parts. We did source them from, say, like Analog Devices or Texas Instruments. So always want to make sure you can get COCs. Make sure you can get lot numbers to do tracking. We'll get to that down the road. Those will be processes and other documentation, other methodologies, other things we'll have to do. But for now, we're not going to work too much about that. Again, this is an evolving process. I know a lot of you come to see the actual design and build, but we want to build up a company. We want to build up processes, a foundation as we go. Again, since the whole idea is not to actually become ISO certified, but to understand the process and try to build up a foundation as you go. That way you support it. That way your business, your ideas are built on it from the ground up. As you build your company, as you build your product. That way when the time comes and it's like, hey, we're ready to go ISO, you've got most of your work done. You've already followed the processes. You've got documentation. You'll have an auditor come in and they'll look at what you've done and say, hey, you're practically ready. They'll tell you things you need to fix. And you might be able to get ISO qualified like right off the bat, get certified right off the bat. It's just about sticking with it. It's something you may never do. And I'm not saying you should do it. But the processes, the methodology, it's sound. It makes sense. It works. And it's recognized through all forms of manufacturing. ISO is worldwide recognized, especially 9001. No matter what company you go to, no matter what industry it's in, no matter what sector, if they're ISO certified, you can go in, ask a few small handful of questions, look for the quality manual, ask where all their SOPs and work instructions are stored, where all their their test results, all their artifacts are stored, and you can pretty much understand how to do any of the jobs at that business. That's what ISO is about. It gets rid of proprietary knowledge. It gets rid of knowledge islands to where one or two people are the only ones that know how to do something. It eliminates that. It makes sure that you can pass your processes down to your new hires, down to your company employees as you grow, as you expand. You don't have to worry as much. That's what all this is about, reducing your overhead. Seems like a lot now, a lot of overhead initially, but in the long run, it will help. It gets easier the more of these processes you get done, the more of the work instructions, SOPs you get written. It'll get easier. So I got this done. It'll all be thrown in with the files on Git, so you can look it over, understand it, follow it, modify it to suit your needs. So we'll get out of code for now. So where we left off is we did the 3.3 volt supply. So this is going to be the main supply for the ESP32. It'll handle pretty much just that. All your main logic, such as switches, like limit switches, control switches, that's all going to be through the ESP32, but it's going to be 24 volt logic. 12 or 24 volt, but we're going to focus on 24. So we're going to be using opto isolators and everything for your inputs and outputs off of the ESP32. So for now, the 3.3 is just to power the ESP32. One of the things I want to do is try to maybe actively cool this device because it's going to be in an enclosure. So real quick, let's see if we can find like a little fan. So I'm leaning towards like the little fans that you use in Raspberry Pis to help keep them cool. They're nice and small. But a lot of them typically are around 5 volts. So we'd have to add a 5 volt power supply. So let's see if we can find something that's a little DC fan. Let's see here. Operating supply. Let's see if we can do. So we've got 2 at 3.3. 1, 17 at 3 volts DC. 3.3 won't really cause a problem. Let's see what we got at 3 volts DC. All right. So it's 15 millimeters. Okay, the prices are what's gonna chew you up on some of this stuff. Now, if you're okay paying a little bit more, but for a fan, I mean, at one section, Sonnen, like I said before, I'm not endorsing any particular company, any particular product. I don't get paid. I'm not a paid endorsement for anything. All I can go by is my experience using these products. And I will say Sonnen is actually a very quality product, and I would not be opposed to dropping it into my device. Let's see here. It's IP55. Since we're going to kind of design everything to blow directly over the heat sink that's going to be used for the stepper driver, I'm not too terribly worried about its actual airflow. This is just to help add a little bit of active cooling. I don't like relying on passive cooling with devices like this, because if that stepper motor is being used in continuous duty, that stepper driver will overheat, will heat up, and I want to eliminate the possibility of it going to thermal shutdown as much as possible. We're going to use 2-ounce copper, which will help mitigate heat. We're going to have a heat sink on this guy, but active cooling, there's nothing wrong with it. So let's assume we're okay with paying $18.47 per unit. Because remember, everything that you put into this at cost, you have to figure out what you want to sell this device for. And you want to recoup every bit of cost. Now, granted, you get into quantity discounts as you go, but let's see, it's 15 by 15, so we're 15 millimeters square. Okay, that's a small little booger. Let's see if we can find something a little bit bigger than that. That's a little guy. Let's see if we can go up to, looks like 17 millimeters, the largest. Let's go back to 5 volts. Now, I know we could do like 650. Let's make sure. Yep, 5 volts. Boop. 30 by 30. Okay, now the prices are getting a little bit better because 5 volts are more common. 5-volt fan are more common. Yeah, we could use an LDO to power the fan, but honestly, I like uh, switching power supplies for things like this. And what are the advantages too? I'll get into after maybe we look at fans here. So that's 30 by 30 millimeters. Let's see, kind of. Okay, that's not terribly bad. 30 by 30. Because remember, I mean, the circuit board, the PCB is going to be a pretty good size. So a 30 millimeter by 30 millimeter by 10 millimeter thick, that won't be too bad. So I'm going to kind of open that new tab. It's 5 volt DC. We're not going to do anything fancy. We're not going to really, it's just going to be constantly running. We could throw some fancy control circuitry in if we want. I mean, we might. I mean, let's just see if there's, let's see. See, we could do a TAC. We can also do a PWM fan. Let's see what's available. Oh, it's a frameless fan. Huh. $65. That's pretty good size. So let's not bother with that. Yeah. Tachometer. Yeah, let's see here. Well, we got auto. Let me start. How many? There's 4 of those. Let's see what we got there. 50 by 50 millimeters. That's a pretty good size fan. It's 40. Oh, wait a minute. Oh, not stocked. It's a Sun-On. 5 volt auto restart TAC PWM. Yeah, let's just see. Does DigiKey have this? Yeah, no, they don't. Okay. That'd be pretty cool. 40 millimeter. Let's see here. Not a bad price. 1063. Because it's got a TAC. Same Sky. If I remember right, they used to be called CUI devices. That I think they were either bought out or they changed their name. Same Sky. Yep, CUI devices. 40 by 40. Yeah, that's not terribly that much bigger anyway. Because we're also gonna have the use pluggables for plugging in your power and your motor outputs. So we're already going to be using slightly larger. It's not going to be like this tiny board. It's not going to be a really tiny board. So we'll actually have room in the enclosure for a 40 by 40 millimeter fan. That's not bad. 1063 to get a TAC and PWM. And since we have to go 5 volts. So what's nice about this is we can use the ESP32 to actually directly control its speed and actually read the TAC to make sure it's actually rotating. So you pay a little bit more money, but we're going to get a little bit more functionality out of it. So we're going to use this fan. So what I'm going to do then is I'm going to go to the operational block diagram, and I'm just going to throw in just kind of like throw this up here. All right. Active cooling. So we're going to just use 5 volt. 5 volt. It's alright. I don't care. I know it copied the formatting from copy and pasting, but I don't really care for the moment. So we'll just kind of like set this off in La La Land for now, because what it's going to be for. So we'll just leave that like that. All right. That way we can go back to it when we need it later. Because we'll have to figure out like a connector for how we want to tie it to the motherboard, the motherboard, the system board. Do we want to tie it directly, or do we want to use connectors, like a JST type terminal? So let's look at the data sheet real quickly, just to make sure. Okay, so the part number. Let's double check the part number. -03 -22. Okay, so according to, okay, let's close that. That's in the way. Okay, so CXX we don't have to worry about. So yes, 22. So it's got the TAC and PWM. So that means it's going to have 4 leads. This means we'll have to do a little extra work to build up and install, but you know, that's not a problem. Yeah, there's a long lead time, but let's see here. I don't know why I close out DigiKey. Available to order. That's fine. Yeah, we'll leave DigiKey up just in case. All right. So it's still, you know, 1100. That's in stock. And news. By the time we get this started and built, it may not be until this. Who knows? I don't know. I'm just messing with you. I think we'll be able to I might maybe next week or so buy a couple of these just to have them in on hand. I might just go and order some just to have a few on hand, or look to see another vendor I can find them on. So with that in mind, we will have to throw in a 5-volt power supply, which is perfectly fine, because the 5-volt power supply is going to be identical to this guy, except the main chip. And the cool thing about the main chip is, so, all right, let's go. Just copy that, even though that's our internal part number, because we just changed that 3 to a 5. I gotta get rid of that. Oh yeah, well, okay, fine. That backslash was fine. Bam. So now we've got the, you know what, let me make sure that's the right part, because that backslash could have screwed up something. 205. Okay. The good thing is, that's a TSOT26SS. It is the exact same part, has the exact same footprint, except for this one's fixed at 5-volt output instead of 3.3. Same thing with 2 amps. So we're going to go over to here. We're going to go to our symbol editor. Open up components. And we're going to duplicate. We're going to rename. We're just going to change that 3 to a 5. Bam. Go to File. We're going to go and save it. Files. File, simple properties. 205, TSOT26. Get rid of that. Don't really need that. 3.3 volts. So we're going to just change that to 5 volts. Just go to 5.0. Vendor 1A part number. So manufacturer part number, easy. 205. Let's get the vendor part number, which I think is almost identical, but we'll just copy and paste just because. $71 and $342, $71 and $342. It's exactly the same price. Perfect. So we're going to go symbol name 205. Okay. We're going to go here to our products. And so we're going to hit new. Get rid of that, get rid of that, get rid of that. Put the 71 cents. All right. So we know our naming scheme. Oh, I hate doing that. Oh, I just messed that up. So my mouse, I've got a gaming mouse. And one of the keys is set up to go back. So it went back without saving it. 71 cents. Category power management. So we're going to go and upload it. We're going back to products. We're going to do some copy that. All right, 3.3 volt, 5.0. Purchase, vendor, Mausa. Grab that guy. I know, lots of fun, isn't it? We're going to upload that. So now that's in our inventory. Now, one of the reasons I'm doing this rather than just throwing in a generic LDO, all right, the biggest reason is let me go back to here. So the schematic is going to be exactly the same. It will be this exact same thing. So these capacitors here, that inductor, that capacitor, these capacitors are all the same except for this guy. So what you're going to do then is you're going to limit, you're going to help control how many unique parts are in your inventory. You're also going to control how many unique parts are in the build. And you're going to be able to take better advantage of bulk prices on things like the capacitors and the inductors. Well, yes, you're going to have two different chips. You're going to be able to stock more of these. You're going to have to buy more of these. So then that means buying a reel is more worth it. Buying 500 is, buying 100 is more worth than buying 10 because you're going to be consuming them. You're going to be using them. And that in the long run actually benefits you. And this power supply design, this switching power supply design, I've used this in several other projects and I absolutely love it. This switching power supply, I plan on probably throwing this exact same thing into other designs moving forward. That that a 2 amp 3.3 volt power supply is all you need. So we will be using this a lot. So for me, being able to buy larger quantity of parts cheaper. So we're gonna try something in because I don't know how KiCad does it. So we're gonna copy this. We're gonna see if we can just do this. Copy it. Okay, we're gonna paste it in. See what KiCad does. Okay, good. Just renamed all the parts. All right, so back in 24 volts, that's fine. .0 volt supply. Okay, it's the exact same thing. So we're gonna delete that. We're gonna place that little guy. Power management 205. And let's see how. Bam. All right, look at that. All right. kind of clean this up a little bit. Drag that guy down there. Drag this guy back down here. And the great thing about that is it simplified our schematic because now we have our 3-point, our getting used to the controls because Circuit Studio and Altium use different input controls, and I might try to match. Oh, let's fix this. Good catch there. So we're going to go 5 volts. Throw that in here. Bam. So 24. Okay, let's double check, make sure we don't have anything too duplicated. So we have our 3 volt, the 203 model. Okay, 3.3 out, 24 volts in, 5 volt supply. Okay, somehow I copied the same chip. What in the world did I just do? 205. Okay, did something get messed up in there? Let's see here. Yes, so something's messed up. So let's get back into our components real quick. Let's see. Oh, you know what? I bet you that's all it was. I forgot to save that. All right, power management. Let's get these. This hidden, not hidden. All right. Ah, there we go. That fixed it. All right, that was my. I forgot to save it. Get that guy down here. Get you guy over here. It just cleans things up. All right, good. Double checked. Okay, beautiful. So that's our 2 major power supplies. They are looking good. And we will go from there. Okay. All right. So that's our supplies. So I guess we should see about throwing in the ESP32. Kind of get that started, that prototyping done. All right. So, we're going to use this guy right here, copy and paste from there to here. All right. Just like everything else, we're going to download the footprint. No, wrong button. Download CAD models. Sign in. All right. Huh. Extract all. I'm about to go through and get all these zip files out of here. That's just getting annoying. All right, please have the KiCad. Oh, that's gonna make our lives a little easier. Component. All right, let's make sure we save this. Let's go back over to our components. All right. So I already kind of started throwing it in here. Wait a minute. Did I already throw it in? Okay. That's right. Okay. I already downloaded that. Do I have it in the footprints? Okay. All right. Footprint editor. Okay. No, I don't. So we're going to file, import footprint. ESP room. KiCad. Oh, hello. Oh, hello. Hello, my little friend. You're going to make my life a little easier. It's actually pretty nice. We're going to save it. We'll kind of keep it this name, which is fine. Well, let's just room 32. I think. UE. Let's kind of UE. UE. Save in components. Bam. All right. Now we're going to do file, footprint properties, 3D models. Delete that. Go here. Throw the step file in. Oh, look how sexy that is. Again, that's just going to be a representation. I just noticed I have a viewer on stream. So feel free to pop in chat. I will do my best to monitor it. If you want to say hi, that's cool. Ask any questions. I will do my best to answer them on stream. Because at the end of the day, they'll always help out any viewer down the road. So we got that. So we have our footprint here. Boom. That makes life a little bit easier. Go back into components. All right. Let's see how this looks here. Let us kind of go into properties. Let's kind of clean this stuff up. You know what? You know what? I messed myself up again. So I'm going to capture this. That way I have my template that I can just use. One of these days I'll actually formalize that into a document. Maybe even try to save like a screen capture of like an example part. But we'll worry about that later. So let's get rid of this junk. Yeah, let's get rid of that junk. We'll go and keep the stuff. Let's give it that footprint. Bam. Okay. Now, as far as the description goes, how are they? Let's copy that text. I don't like that. Okay. You know, let's only keep the extremely relevant stuff. Get rid of that. 16 megs by flash. So if there's any other details we want it, I mean, we pretty much know what we want here. Let's go and get the negative 40 to plus 85. And then Rojas. So we're going to add our menu. Now, did I have that right? Espressive. This is just, even though there's only going to be one real manufacturer of this product, this is just to maintain consistency, because when you generate the bill of materials that way, it's just consistent across the board. And then also getting into the habit. That way you just stay consistent. All right. All right, so let's go. Let's copy their part number. And then 671. 671. Man, prices have gone up. Now, since we're looking at full quantity, since a full reel is 650, let's just go in 398. We'll just go and put that as the quantity. Because if you order 1,000, you're still going to be at 398 per unit rather than 373. You have to get 1,300. So 398 for your bulk quantity. All right, so we got that. We got that. Yep, I know I should have done this. Yeah, the reason I didn't give it any fancy name, I just left it that, is things like the ESP, SOMs like this are, you pretty much know what you're looking for. This is an ESP32. It will always be an ESP32. So in your inventory management system, so we're going to go to products. We're actually go to new. All right. Purchase Mauser. Vendor product code. And it's 671. No information. That's goods. Tax. Now we're going to put this under, we're going to create a new category. We're just going to call it MCUs. This technically is a microcontroller unit. It's going to be goods. Save. And then our reference is going to be the description. Boom. Boom. Let's go get rid of that space. It doesn't like it. Okay. Pump, 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 pump. Right, we're going to upload that. Come back here. Clean up that space here. Okay. Now, one of the things I want to do is get this stuff dragged out of the way. Come on. Ansel. Come on. Since this only shows up here. Right. Hey. Stop doing that to me. Yeah, we'll worry about this later. So, one of the things I like to do is to look at how it's organized and kind of redo some things. Like, I don't like how again, as long as your pins have their number here, as long as their number is there, you're going to be okay. It'll map to the footprint just fine. I like to change things around to make things more readable for human beings. Hey, come on. Drag you out, drag you out, drag you out. Alright, so ground 3, so we're gonna, come on. Wow, so annoying. Ground 2, ground 1. And then any of the NCs we're gonna drag over there too. NC7. All right. Eh. All right. That just makes it easier for a human readable. And when you throw it into the schematic, it gets a lot easier because then you can tie all these grounds together to your ground and be done with it. And then 3.3 volt, I like to drop up here along with the enable, and then start rearranging all the IOs. So now there are some things to consider. Um, the sensor VP and VN. Can we electrotype? They're input only. And then I think 34 and 35 are input only. So what we're going to do is we're going to go here. Control F. GPIO 34, I think. Yes. So 34 and 35 are input only. I learned that the hard way. So we're going to go ahead and make the definitive right in there. You stop doing that to me. Stop. Stop. All right. So I'll leave those guys here, VP and VN. Let's see here. Okay, that's okay. So they'll be also 36 and 39 VP. So you can use them as GPIO inputs. 36 for VP. I 36 and IO 39. All right. Okay, now that we got that, so one of the things we can do is just kind of clean this up, slap things in there. But sometimes I get a little bit of OCD. It gets weird sometimes being me. So IO 0. Do we want to input output? Okay, yeah, bidirectional. IO 0. IO silver. I mean IO 1. Okay, there's no IO 1. It's probably borrowed by an onboard part. GPIO 1. Yeah, there is no IO 1. Perfectly fine. So IO 2. Stop. Okay, IO 2. There's no... These kind of out of the way. There's no IO 3. So we got IO 4. Bidirectional. IO 5. IO 6. Alright, it does not look to be an IO6. So is there an IO7? Alright, looks like IO12 is the next available IO. Bidirectional. Yeah, here's where things get really fun and really boring. Cancel. Probably could have just went ahead and taken the opportunity to fix it, but who cares? 12, here's 13. $14. 15. It's just my OCD. I don't know why I like to do this. It's just the way I like to have my pins organized in my schematics. I don't know why. 16. 16. 17. Becomes a game after a while trying to find the pin. Find the pin! 17. Do we have an 18? Yes, we do. We might have a bingo if we're lucky. Alright. There's no 20. So there's a 21. 21. There are 22. 22. Do we have a 23? Yes, we do. No, bidirectional. 23. No, 24. We have a 25. 26. Might as well fix that while we're here. 27. 28. There's a 32. Here's a 33. All right. So what we will do then is go put that there. I've already changed that. Put that there. Go put these guys. Don't really matter. Put that guy there. It'd be nice if I could just shift select all these guys. There we go. Move you down here. Move you over here. There we go. Let's make sure that's saved. We're going to go back to our schematic. Actually, I think we have to go back here. No. How do we add another sheet? All right, let's see here. File. Place. We're not going to import a sheet. We're not going to really do hierarchical. We're just going to be kind of like open. So I guess we have to go here. Actually, to the project. Or go file. Oh, wait, oh, maybe here. File. Maybe up here. File. All right, we're in the schematic editor. Yeah, so I got to figure out how I'm going to add another sheet to this. Preferences, tools. No, I'm not going to do that. Sheet 1. Okay. Oh, wait a minute. It's kind of so that way I can have KiCad and I can look up real quick here. Okay. Rectangle. All right. What I'm looking for. You're not being very helpful. You're not being very helpful. I'm on. All right. Okay. I'm not looking. Trying to figure out how to add a sheet. Place a hierarchical subsheet. Wait, what? Wait a minute. What? Okay. So let's go to the project directory. Damn it. Damn it. Hardware. No, you're not being very helpful here. That's the project. Okay, this is getting kind of annoying. So sheet name will be 32. Oh, okay. Okay. We might have to figure this out, but that's fine. I'll just leave it alone. It's fine. We'll figure this out here. We're going to copy that. We're going to go here. We're going to go here. We're going to put here the title. Let's call it ESP32. Get rid of that. Hit OK. Boom. Gonna save it. Okay. All right. That was a little bit bonkers, but hey, it works. We got it. I'm going to go ahead and place this. We're going to place the ESP32 that we just built up. Smack that guy in there. No. All right. Let's drag you. I'll put you down here at the bottom. And I'll move you over here. Okay. So we already know we're going to need 3v3 and ground. Put that there. We're probably going to want one up here, maybe a couple. We'll figure all that out. Okay. What's good is the work we did rearranging pins 34, 35, 36, and 39. All those GPIOs are input only, and that'll kind of help us. It kind of helped us in the long run. So we know, let's see here. Okay. So for the enable, the ESP recommends a basically a delay circuit for the enable pin. So that basically what allows the ESP32 to actually power up and function. There's a real quick circuit. It's usually just a 104 cap and R1. Yeah, so off of this R1, do you give me R1? Recommends for RC delay circuit is a 10K and a 1 UF. I've never gone that much. I think I've done 104 cap, and I have to double check the resistor that I've used before on some of my past designs. But I don't need that open. My goodness, you are annoying me. Okay, so, but because I know I'm going to want that cap, that 104, we're going to go pop that guy in here. Okay, that's going to be our 104 cap. Like I said, I'll dig up, see what resistor value I've used before in other designs. It seems to work just fine with the 104 cap. So that'll control the enable circuit. It basically delays power on for the ESP32 to give the power supply a chance to stabilize. And usually with switching power supplies, they go pretty quick. We're also kind of, let's see here. 12, 6. those are some heavy duty caps. Those are 25 volts. We'll see if we can find some 22 microfarad at around like 6 volts. We'll use for some bulk capacitance on the input side of this. We're also going to throw in another 104 cap to help filter noise off the 3v3 line. We'll get all this cleaned up. I'm going to go and end the video here. We're at an hour. I'll get things cleaned up, organized, and I'll push everything to Git so it'll be updated to where we are now. The next video we'll pick up, we'll add more components, and we'll start building out the ESP32 circuit at least. We'll definitely be adding more sheets to this. I might see about fixing this a little bit better, reorganizing this a little bit, maybe give it a different route, kind of move everything over. We'll see how it goes. Not 100% sure. Again, KiCad's new to me. We might just leave it alone. What's not broken, don't fix it. As long as everything translates over the PCB, we should be fine. I thank you, everybody, for watching, and leave any comments. Let me know. I'll get this video edited and thrown up on YouTube, hopefully by the beginning of next week. Hopefully sooner, because what I want to try to do is get all the videos I've done so far, get them up on YouTube, and then maybe come up with like a release schedule. I don't know. We'll see what we can do. All right. Thank you, and catch you guys next time.